We're going to continue our study on other types of equations by looking a little bit more at radical equations, some more complex radical type of equations, and we'll also look at fractional equations. So let's look at this example. 5 plus the square root of 3x minus 11 is equal to x. Now the first thing I'm going to do is I'm going to get the square root by itself before I do anything else. So I will go ahead and subtract the 5 over to the other side. So now I have the square root of 3x minus 11 equals x minus 5. Now I can square both sides. That leaves me with 3x minus 11 on the left, and then for the x minus 5 squared on the right, I'm going to have to multiply that out. Remember, this is the same as x minus 5 times x minus 5. So this is 3x minus 11 equals x squared minus 10x plus 25. Now, let's group everything over to one side. So I'll go ahead and subtract the 3x, add the 11, so I have x squared minus 13x plus 36. And then we can try to factor that, and this is factorable. It becomes x minus 4, x minus 9. So we can set each of those equal to 0. And then solve, so we get x is equal to 4 and x is equal to 9. Now don't forget that for these types of equations, we need to check our answers in case we have any extraneous solutions. So plugging it back in, plugging 4 back in, we have 5 plus the square root of 3 times 4 minus 11 equals 4. Now 3 times 4 is 12 minus 11 is 1, so 5 plus the square root of 1 is equal to 4. That is not true, so x cannot equal 4. Check the second answer. Plug 9 in, so 5 plus the square root of 3 times 9 minus 11, so 3 times 9 is 27, minus 11, that's 16. So we have the square root of 16, which is 4, so 5 plus 4 equals 9. That does, in fact, work. So x equals 9 is going to be the solution in this example. Now, in some radical equations, you may have more than one radical. So up to this point, to solve radical equations, we have been raising both sides to some power to get rid of the radical. And in some cases, if you have more than one radical, you are going to have to do this twice. Let's look at example 7. We have the square root of 2x minus 3 minus the square root of x plus 7 equals 2. So we want to start off the same way. I want to pick one of those radicals to get by itself on one side, and then we're going to square it, simplify it, and then we'll try to get the other square root by itself, square that, and then we will be able to work with that equation. So I'm going to start by getting that square root of 2x minus 3 by itself on the left. So I'm going to add the square root of x plus 7 over to the other side. Next, we're going to square both sides. So this leaves us with 2x minus 3 on the left, but on the right here, we're going to need to multiply this out. This is the same as the square root of x plus 7 plus 2 times the square root of x plus 7 plus 2. So now we have the square root of x plus 7 squared plus 2 times the square root of x plus 7 plus another 2 times the square root of x plus 7 plus 2 squared. Now, notice here I have this 2 times 2 here, and that's because we have 2 of those, right? We have the outer terms multiplied together gives you 2 times the square root of x plus 7, and the inner terms multiplied together gives you 2 times the square root of x plus 7. Alright, so now let's try to simplify as much as we can. So we have x plus 7 plus 4 times the square root of x plus 7 plus 4. Now we want to isolate the remaining radical, right? So we were successful at getting rid of one of the radicals. Now we need to isolate the second one before we square both sides. Now, we can absolutely leave that 4 next to it. It's part of that term. Just that when we square it, we want to make sure we square the 4 and we square the square root of x plus 7. Okay, so I'm going to go on to the next slide, but we're going to start off with the same line here. So now we're going to square both sides again. So remember, this x minus 14 squared, you're going to have to write this out as x minus 14 times x minus 14 and distribute. So this will be x squared minus 28x plus 196, and then make sure you square everything on the right, so that would be 4 squared, and then the square root of x plus 7 squared. That leaves me with 16 times x plus 7 on the right, and we can go ahead and distribute. Now you'll notice that all the radicals have now disappeared, and now we can solve this as a quadratic. So now I'm going to move everything over to one side. So I have x squared minus 44x plus 84 equals 0. Now let's go ahead and try to factor this. So we're trying to find two numbers that will multiply to positive 84 and add to negative 44. That would be negative 2 and negative 42. So that would be x minus 2, x minus 42 equals 0. Set each factor equal to 0 and solve. And that gives you x equals 2 and x equals 42. Now we want to go back to the original problem and plug it back in. So we'll try with 2 first. So we have the square root of 2 times 2 minus 3 minus the square root of 2 plus 7 equals 2. So we have the square root of 1 minus the square root of 9. So 1 minus 3 equals 2. That does not work. So x equals 2 is extraneous, and you can check 42 as well. So we have 2 times 42 minus 3, that's 81, so the square root of 81 is 9, minus 42 plus 7, that's 49, square root of 49 is 7, so 9 minus 7 does in fact equal 2, so x equals 42 is a solution to this problem. Let's do another example where we have multiple radicals in the same equation. The square root of 5x plus 6 equals 3 plus the square root of x plus 3. So it looks like we already have one of those radicals isolated on one side, so I'm going to go ahead and square both sides. So I have square root of 5x plus 6 squared, 3 plus the square root of x plus 3 squared. So on the right here, I'm going to write this out, 3 plus square root of x plus 3 times 3 plus square root of x plus 3. All right, so now we have 3 times 3, that's 9, and then we have 3 times square root of x plus 3, another 3 times square root of x plus 3, and then we have root x plus 3 times root x plus 3, which is just x plus 3. Now this 3 times the square root of x plus 3, since we have that twice, we can add those two together, and we get 6 times the square root of x plus 3. And now we want to isolate the radical. So I'm going to subtract the 9, the 3, and the x over to the other side. That leaves me with 4x minus 6. Now again here, you could divide both sides by 6 to completely isolate the radical, but because that number is multiplying the radical, you can consider it as one term. And so when you square it, just be sure you square the 6 and you square the square root as well. So I'm going to go ahead and square both sides from here. So now we have 4x minus 6 squared. Again, remember this means 4x minus 6 times 4x minus 6. And then on the right, make sure that you square the 6, so that's 36, and then x plus 3. Now we've gotten rid of all the radicals, and it looks like we have a quadratic that we can solve. So I'm going to distribute the 36, subtract it so that we only have 0 on the right-hand side. So we have 16x squared minus 84x minus 72 equals 0. And now just to simplify the problem, it looks like all 3 of these coefficients can be divided evenly by 4. So this gives us 4x squared minus 21x minus 18 equals 0. And then we'll go ahead and factor that. You may need to split the middle here. But once you have it factored, you should have 4x plus 3 and x minus 6 equals 0. So our two answers are x equals negative 3/4 and 6. Again, you want to go back and check your answer. So check it right back in. The original equation, plugging -3/4 in, and then plugging 6 in. Make sure that you're plugging in the same value of x for that equation. So the square root of 5 times -3/4 plus 6 equals 3 plus the square root of -3/4 plus 3. Check that. And then plug 6 in and check that. So square root of 5 times 6 plus 6 equals 3 plus the square root of 6 plus 3. In this case, -3/4 does not work, but 6 does. So our answer is x equals 6. All right, the next type of equation that we're going to talk about today are fractional equations. So fractional equations are equations of this form, where you have a function in the numerator, a function in the denominator, and it equals 0. Now, the solutions to fractional equations are going to be all values of x, where f of x is equal to 0, but g of x is not equal to 0. So in other words, anything that makes the numerator equal to 0, that doesn't make the denominator equal to 0, will be a solution. Think of it this way. You're going to take the numerator, set it equal to 0, and solve it. And then to check your answer, check to see whether or not it makes the denominator equal 0. If it does make the denominator equal to 0, then you can consider that to be an extraneous solution. But if it doesn't make it equal to 0, then that's a solution. Let's take a look at example 9. We have 6x squared minus x minus 1 all over 2x squared plus 9x minus 5 equals 0. So I'm going to start off with the numerator, and I'm going to set that equal to 0 and solve. So we have 6x squared minus x minus 1 equals 0. Now I'm going to factor this. You can do this by splitting the middle. This ends up being 3x plus 1 times 2x minus 1 equals 0. And solving that, we get x is equal to -1/3, and x is equal to +1/2. Now that you've solved for our solutions to the numerator, you're going to check and see whether either of the solutions will make the denominator equal 0. So we're going to put -1/3 in for x in the denominator. So in this case, we have 2 times -1/3 squared plus 9 times -1/3 minus 5, and that gives you -70 over 9, which is not equal to 0, so that looks like that's fine. And then we can plug 1/2 in. We have 2 times 1/2 squared plus 9 times 1/2 minus 5, and that's equal to 0. Now, since that's equal to 0, that means 1/2 will make the denominator equal 0. So this is not going to work. That means that the only solution for this problem is -1/3. Let's do another example. 2x squared minus 3x minus 4 all over x minus 4 equals 0. We're going to start with the numerator, so we're going to find all solutions for 2x squared minus 3x minus 4 equaling 0. Now, see if that's factorable. But in this case, it's actually not factorable. So if it's not factorable, then what do? Well, then you're going to have to use the quadratic formula. X equals 3 plus or minus the square root of 3 squared minus 4 times 2 times -4 all over 2 times 2. Now, inside the square root, we have 9 plus 32. That gives us 41, so we have x is equal to 3 plus or minus the square root of 41 over 4. Now we're going to discard any solutions that make the denominator equal to 0. In this case, it's actually pretty easy to tell whether or not the solutions that we just found are going to make the denominator 0, because x minus 4, well, what value does x have to be in order for that to equal 0? It would have to equal 4. 4 was not one of the solutions that we found in the numerator. So that means that our answer is going to be 3 plus or minus the square root of 41 over 4. Neither 3 plus the square root of 41 over 4 or 3 minus the square root of 41 over 4 will give us 0 in the denominator. So today we went over Radical equations where you have more than one radical in the same equation, in those problems, you're going to want to do the same thing, isolate the radical, square both sides, simplify, and then you'll have to isolate the radical again, and then square both sides again until you can simplify it down. With fractional equations, you want to take the numerator, set it equal to 0, find the solutions of the numerator, and check to see whether or not any of those solutions you just found would make the denominator equal 0.